everyone, and welcome to lesson number 5. Today I will keep the lesson as short as possible and make some examples regarding the operators. So imagine that we create a game. Open your Eclipse program, close the welcome screen, and you should see our last project. So then click the new Java project. We will create a project named, for example, lesson 5 vision operators. Click finish. Then right click, package, finish, right click, new class main, public sector void main, and here we are. So as I said, imagine that we create a game. I think that you all play games. So integer winning score, and we will assign a value of 20, and another integer current score, and we will assign it a value of 0. So we made a small introduction to the if statement, and we will continue this small introduction in this lesson. So we will say if current score equals winning score, then system out print line, and we will write congratulations, you won the game. So, and then we will write another if statement, if current score is smaller or is less than the winning score, then we open the brackets, we create a system out of print line, and we will write sorry you lost, try again, or it will be even more polite, please try again, and the bracket closes. So we should be able to check everything now. So integer winning score 20, your current score is 0, and we say if the current score equals the winning score. So if your current score is 20, if you hit 20 points in this game, then the system will tell you congratulations, you won the game. But if your current score is less than the winning score, then the system will tell you sorry you lost, please try again. So fair enough. I think that's how all games work. So our current score is 0. Let's see what's the result. Sorry you lost, please try again. But if we score 25, then 20, I'm sorry, then congratulations, you won the game. And what I did wrong before is that we don't have a value for something from a score greater than the winning score, so we will create it now. So current score, if your current score is greater than the winning score, then we will open the brackets and we will write here, you nailed it, it's easy. Congratulations. So if we hit now 25, then you nailed it. Congratulations. So let's go further and create some more integers. So speed car 1 equals 150 and speed car 2 200 and int integer speed limit, something that all drivers know, 130. Here in Switzerland it is 120. In France is 130. In Greece is also 130. In Germany at some points is unlimited, at some other points 130. So I will keep the 130 kilometer. So now how can we test it? We say if, and so you can see how the if statement also works. So for the lessons that will come, it will be even easier for you to understand it. So we say if the speed of the first car is greater than the speed limit, and also this is the logical and the speed of the second car is also greater than the speed limit, then we open the brackets and we say, so it's, and then we open the brackets, we write the system out print line and we say both drivers will lose their driving license. So what do we miss here? We miss a parenthesis. Why? If the speed of the first car is over the speed limit and the speed of the second car is also over the speed limit, and then comes the police, then both of the drivers will lose their driving license, at least their driving license. Is it correct? I think so. So then we say if we open double parenthesis, speed car is greater than the speed limit, and then we will use the logical or the speed car 2 is greater than the speed limit, then we will open our brackets and we will say what will happen. So at least one of the drivers will lose their driving license. And then we will create another one, and then we will say if the speed car is less than the speed limit, and logical and the speed car 2 is also less than the speed limit, then we open the brackets and we will say, we will write what will happen. Both drivers will keep the driving license. So let's see now. What did we say for the logical AND? That both of the parts, left and right of the logical AND, should be true in order for the result to be true. And for the logical AND, if one side, at least one side, is true, then the result will be true. If not, if both of them are false, then it is going to be false. In logical AND, if one side is false, then the result will be false. So let's see here. The speed car is 150 and the speed car of the second car is 200. Both of them are over the limit. So let's see what happens. Save it, and both drivers will lose their driving license. This is activated because both of the parts are true, and at least one of the drivers will lose their driving license. Will lose his driving license. So why? Because at least one of these two statements is true. If we put these to 50, both cars run with 50 km per hour. So, and the speed limit is 130. So let's run it. Both drivers will keep their driving license. Why? Because they have discipline and they run with only 50 km per hour. And I think that we saw everything here. Let's do something else. Both of them are run with 150. Is that correct? Yes, because these two are activated, and we will say this one. So at least one of these two is false, because speed car 2 is not equal to the speed limit. Speed car 2 is 150, speed limit is 130. So this should be false. This should show nothing to us. See, we take only this result because only one of the two statements. Let's put it also here. We should take it again. Great, because only one here with logical OR, only one of the two statements is true. That means that the whole statement here is also true. And that's why we take as a result the text we put here, because in logical OR, if left or right is true, then we will take what's inside the brackets. But with the logical AND, it is not the same. We have this part is false, and then the compiler doesn't run the code that is inside the brackets. So let's go further and this one with some Boolean practice. So we will create a variable from the data type Boolean. Boolean is always true or false, either true or false. So the sky is black, and we will assign it a value of false. So what that does mean is that the sky is not black, because we say here the sky is black, and then we say it's false. That means it's not black. So then we do write if the sky is black, then we will write here so it is late, you should go to sleep. Let's run it. So we don't get any results, any outcome from the compiler. Do you know why? Because here we say if this statement here is true, then run, compiler, please run this code line. But our statement here is false. That's why compiler ignores what's inside the brackets. If we say here true, the sky is black. It is true. Then let's run it. It is late. We should go to sleep. Another typo here. So we should go to sleep. So I hope that you understand that you begin to understand how it works. And then I will show you a last thing here. So boolean the sky was black. I create another variable. What I will show you now is not for our current level. We will see it later, but why not? You can see it and learn it also right now. It's not that hard to understand. So we create now another variable. The sky was black, and we will assign it a value. The sky is black, or this variable here, and then question mark, true, false, and semicolon. What we do say here is, let's see it also in action. The sky was black. Perfect. So what we do say here is, if the expression before the question mark here, if this expression is true, if that is true here, then it is true. If that is false, then that is false. And our result, true or false, will be given as a value to this new variable, that we created. The sky was black. So we see here, the sky is black. Is it true? It is true. So this whole thing here is true, and we assign it, this whole thing to this variable. So the sky was black should be true. Let's see. True. If we assign this as false, and we save, so it means that what is behind the question mark? The sky is black. Is it false? It is false. So the whole statement here is false. And we put this here, we assign it here in the sky was black. So we call now the sky was black, and it should be false. False. So that was it. The duration was a little bit more than I expected, but I do hope that you now understand the basic concept of the data types and the operators, because we will work a lot with all of them. So if you didn't do it already, go and check up our challenge, our first challenge, try to solve it and create your program, a program that you can also use in your real life, in your everyday life. So thank you guys for watching.